For more than 100 years, some of the brightest minds in India have been on an epic quest, trying to predict one of the most powerful weather forces on the entire planet. We are, of course, talking about the Indian monsoon. It's a force that literally defines the lives of over 1 billion people. So today, let's trace this incredible story of science, of survival, and the absolute obsession with getting the forecast right.
To really get why this matters so much, you have to start with this number right here, 70%. That is how much of India's total yearly rainfall comes from the southwest monsoon. I mean, think about that. It's not just rain, it's the absolute lifeblood of the nation's farms, its economy, and its people. But here's the thing about this lifeblood. It's got a dark side. It has a dual nature. You see, when the monsoon is good, life is good. It brings prosperity. But when it fails, it can lead to these long, devastating droughts. And if it's too strong, you get catastrophic floods. The stakes are just unbelievably high, which is exactly why trying to forecast it became a national obsession.
So how did we even get to where we are today? Well, we're going to trace this whole scientific journey. We'll start with the crisis that kicked everything off. Then we'll meet the brilliant pioneers who found the very first clues. After that, we'll see the massive leap to supercomputers and find out how India is now taking charge of its own forecasting destiny. And crucially, we'll connect all that high-tech science to the farmers on the ground. And finally, we'll take a look at what the future holds.
Okay, so our story really begins with a total disaster. The drought of 1877, it was a complete turning point. The monsoon failed, and it failed badly. And that made it terrifyingly clear that just reacting to the weather wasn't going to cut it anymore. No, India had to find a way to see it coming. This catastrophe is what launched the modern scientific quest to forecast the monsoon.
So who were these pioneers? Who were the first people to even try and take on this challenge? Well, back in the late 19th and early 20th centuries, a few brilliant meteorologists started digging for patterns in the chaos. And you got to remember, they were armed with basically nothing. Barometers, thermometers, and just their incredible intellect. No satellites, no computers.
And the science grew in these really fascinating steps. It all started with H.F. Blandford. In 1882, he made this huge connection between the amount of snow in the Himalayas and drought in India. That insight led to the very first official monsoon forecast just a few years later. Then you had Sir John Eliot, who meticulously charted out pressure and wind, creating what he called the monsoon experiment. But the real game changer? That was Sir Gilbert Walker, who realized the monsoon wasn't just a local Indian event. Walker gave us this completely revolutionary idea, teleconnections. He figured out that the Indian monsoon was actually connected to this vast global web of weather patterns. I mean, things happening thousands of miles away, say in the Pacific Ocean, could have a direct impact on how much rain falls in India. This was a radical idea, a huge shift from just local observations to a truly global way of thinking. For decades, Walker's statistical methods were the best thing going. But they had their limits, you know? They often completely missed the really extreme years. The next great leap forward would need a whole new kind of power. The power to basically simulate the entire planet's atmosphere inside a machine. This was the dawn of the supercomputer era.
This slide really breaks down the massive shift. The old statistical models, they were all about looking for historical patterns. You know, if X happened in the past, then Y will probably happen now. But the new dynamical models? Totally different game. They use supercomputers to build a digital twin of the Earth, run by the actual laws of physics, and then simulate how the atmosphere and oceans are really going to behave. And, you know, building these unbelievably complex models wasn't something one person could do. It wasn't even something one country could do. It took decades of international teamwork. You had programs like Monex in the 70s, TOGA in the 80s, and AMIP in the 90s. All of these brought scientists from all over the world together to observe, to understand, and to compare their models, constantly pushing the science forward and making the forecasts better and better. All that global progress really paved the way for India's most ambitious project ever. By the 21st century, India basically decided it was time to take control of its own forecasting destiny. It was time to build a world-class system that was specifically tailored to the subcontinent's unique challenges. And this was the birth of the Monsoon Mission. The mission was launched in 2012 by the Ministry of Earth Sciences, and its goal was crystal clear: create the absolute best prediction system for the monsoon possible, across all time scales. As this quote puts it, it was all about clearing the gap between research institutes, bringing national and international experts together to tackle this immense challenge head-on. So what's the engine at the heart of the Monsoon Mission?
It's this amazing piece of tech called the CFS V2. It's a fully coupled model, which is a fancy way of saying it doesn't just simulate the air, it simulates the oceans, the land, and this is the crucial part, how they all talk to each other and interact. This whole system approach is the key to modern, accurate weather prediction.
Okay, so we have these incredibly powerful, complex models running on massive supercomputers. But let's be real, what does any of that actually mean for people on the ground? The most important step is connecting all this high-level science directly to the people whose livelihoods depend on it. And that brings us to our next critical number, 53%. Over half of India's agricultural land is rain-fed. That means it depends directly on the monsoon, not on irrigation systems. For millions and millions of farmers, an accurate forecast isn't just some interesting piece of science. It is absolutely essential for survival.
So this is the million-dollar question, isn't it? How do you take petabytes of data from a super complex climate model and turn it into simple, practical advice that helps a farmer decide when to plant their seeds? Well, the answer lies in a pretty brilliant system of translation.
And the answer is the Agromet Advisory Services, or AAS. This service is basically the translator. It takes those complicated forecasts from systems like CFV2 and turns them into clear, actionable advice. Farmers get bulletins that tell them the best time to plant, how to manage precious water, they get warnings about potential pest outbreaks based on the coming weather, and even advice on when the best time to sell their crops might be. This is where all that science truly meets the soil.
We've made such incredible progress since H.F. Blandford first looked at the snow on the Himalayas. But this work is far from over. In fact, as our climate changes, the challenge is only getting bigger. The scientific quest has to continue, and it has to get faster.
So what's next? Researchers are now tackling a whole new set of frontiers. They need to get way better at predicting the most dangerous things, those extreme events like flash floods. There's a big push to improve forecasts for the northeast monsoon, which often gets overlooked. And of course, they're bringing in new tools like AI and machine learning to spot patterns that we might be missing, all while trying to build a better, more centralized network to just observe the weather in the first place.
And all of that leaves us with the ultimate question. We know the climate is changing. The monsoon is becoming more erratic, more unpredictable. The scientific journey to forecast it has been nothing short of remarkable. But now it's a race against time. Can our models, our computers, and our understanding of this magnificent weather system evolve fast enough to keep up? That is the challenge for the next generation of monsoon forecasters, and it's a question that will absolutely